Hello, are you alright, Mr. Eric, Mr. Ryan?
Yeah.
Okay, so today we talk about another problem which is called the longest substring. Yeah, we know the longest substring. Remember, a few days ago we talked about the longest substring with at least two distinct characters. Remember?
Yeah.
And we used the two sliding window thing. Yeah, sliding window. Okay, so today we talk about a similar problem with longest substring. But we want to make sure that each character in the substring has at least k, with at least k characters. What does that even mean? K at least k times, appearing at least k times. Okay, let me give you an example. A, B, C, C, D, D, E, F, G. If k, this is S is this string, yeah? And if k equals 2, what does it mean? So what kind of substring can you find in this given string?
A lot.
A lot. And which one? Yeah, can you find the one which has the longest? It's the longest, and every character appears at least 2 times. So every character appears at least k times. So for example, like, is this a requirement? A, B, C, C. By the way, the substring is continuous, right? Yeah,
No.
substring. Yeah. But subsequent is not. So for example, subsequent you can pick A, C, D, F, G. Yeah? Subsequence is a string that you delete one or more characters from the original string. Yeah? You can delete one or more and it becomes a substring. But we are talking about a substring, a subsequent. We are talking about a substring. Okay, subsequence is you delete one or more character from the original, that becomes a subsequence. But substring is that it has to be continuous, right? So look, this is a substring A, B, C, C. And can you tell me if there are at least, if each character in the substring appears at least twice?
No.
Because A appears 1, B appears 1, 0, yeah. Okay, so we want to look for the...
C, C, D, D.
Okay, C, C, D, D. This is the longest. Well done, yeah? Yeah, because each one appears at least twice, right? And then it's the longest. You can't find any more which is longer than that, right? Yeah? So how can we do this with the substring? You know, every problem, almost every problem, yeah, with a substring, the first idea is to do what?
Brute forcing.
Yeah, brute forcing, because we can easily brute force, right? What's the time complexity to brute force a substring? Substring. Look, if this is a substring, how do we brute force a substring? How do we brute force a substring? Brute force the substring. How do we brute force it?
We just check every sliding window.
Yeah, the substring is have a from index and to index, yeah? From index to index. For the position when it starts and the position when the substring ends. So we can brute force this, right?
Yeah.
So for if the length is n, then we can do this for I in range n, and then for j in range I, or for j in range I n, right? Got it? So that's in O n square, right? Right?
Yeah.
Okay, so once we have a substring, we can check if each character appears at least k times. How can we check it? Remember, how can we check it?
Just.
Remember, when we said we want to count the number of characters appearing in a substring, in a string, what kind of data structure, what kind of thing we can use to do this, to count, what's that?
Counter.
Counter, yeah. Okay, so let's implement this brute forcing first, okay? Define, okay, let's just call it full as k. So n equals length as first we want to get the length of the string, yeah? Eric, what you doing?
Nothing.
So we want to, so how can we write the brute forcing? Come on. For I in range n, right? This is the left part, yeah? And then, sit there please, so I can talk to you. Sit there please.
How about Ryan?
Ryan, can you sit there please?
I'm still looking.
For j in range what? What's j in range what? Come on.
I know.
Which one? So look, I is
Left.
there are two ways of writing it. You can write, okay, so if the string is Sij plus 1, so
I am.
I and we're done.
I said that.
Okay. Or if you can do it if j I plus 1, right? Then you can do for j in range I. Okay. It's just almost the same, right? Okay. So now what's the substring? X equals s I to j plus 1, right? Okay. So this is the substring. Now we want to check if the substring contains at least k numbers. Now we put it in a counter. C equals counter x. Right? Yeah? Now we have a counter. So C dot value. If it's the substring, C dot values. So how can we check if all the characters appear at least k times? Using the C dot values. Remember what's in the counter? Counter keys are the numbers, yeah? Are the characters, yeah? And the values will be what? The number of times they appear, right? And if the minimum of C dot values, if it's still bigger than k or equal than k, what does that mean? What does that mean? If mean C dot values bigger than k, bigger or than equals k, what does that mean? It means what? What does it mean? If the values, the minimum values, look, as I said, the keys are the number of the characters, and the values are the number of times they appear, right? In the substring, right? In the string. If the minimum of the values is bigger than k, what does that mean?
It means that it's not.
That is what? That is what? That is what?
There's
Each character appears what?
at least k.
Yeah, yeah. And then we want to remember the longest. Answer equals 0. And answer equals what? Maximum answer. And then what's the length of the substring? J minus, or length x, or you can say j minus I plus 1, right? Yeah? And return answer, yeah? What's the time complexity? Come on.
Square.
How about this?
Cubic.
Yeah, look, don't forget this. This is O n cubic. What's the space complexity? Any space we're using? Yeah? There? When we say counter, we are using space, right?
Yeah.
Because we decide the notebooks in ON, yeah, we're done. Right? Yeah?
That's slow.
Let's slow. Can we do better? Can we do better?
Yeah. Because why you asking that?
Okay, so again, this one, okay? A, B, B, C, C, D, B, E, F, G, okay? K equals 2, okay? K equals 2. So what's the longest? K equals 2, what's the longest? What's the longest substring that every character appears at least 2? What's the longest you can find?
B, B, C, C, D, D.
Yeah, you see? Okay, so now, if I said, if I know a character, if I know a character, look, if I know a character which only appears once, less than k times, can it be included in the longest substring? If like E, F, G, A, E, F, G, they appear once.
Yeah.
Can these letters be included in the final longest substring?
No.
No, that's right. Because we are looking for the string that can every character appear at least k times, right? So this is at least every character.
No characters appear at least k times.
Good job. Then empty string. Yeah.
Oh.
Or 0, yeah. We return the 0. Return the 0. Okay, so look, because we're looking for every characters that appear at least k times. Then if we find out this character appears less than k times, right? Less than k times. So it cannot be included in the final string. So what does it mean? So it means that we can split the string into these characters. So let's do this. Look. Maybe this is not a very good example. Let me write another example. Okay, let's say A, K equals 3. Okay, K equals 3. K, A, B, B, C, C, C. Okay, and then D, D, E. Okay, what's the answer that appears? What's this answer for every substring? The longest substring that appears, that for each character in the substring appears at least 3 times. What's this? Can you give me what's that?
CCC.
So that's the only substring that satisfies this requirement. Okay.
Oh,
So look,
what?
if let's say look,
There's loads of A's.
yeah, look the one answer. What I'm saying is that look this A, this A, what is the count? How many it appears in the whole string?
1.
So it's less than K, right?
Yeah. So we go to the next one.
So it's less than K. So we can divide this A into two parts B, right? We can divide this into 2. Because what does it mean? Because we can divide it by A. Look at this another A here, and another A here. Okay. So look, A, as I said, A cannot be included in the final string, right? Because it only appears less than K times, right? Yeah. So we can split the string, the entire string, in by A. So we have what? We have B, C, 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 D, D, E, right? We have these, right? Yeah. Because A, we can just ignore it, right? Because it can't be included in the final string, right? So B, so the answer will be the maximum of the recursion. We solve the left part, solve this part, right? Do you get it? So we have a function to solve this problem, and then we now
If there's
split.
more than 2.
Yeah. What? Which one?
If there's more than 2 parts.
Yeah, if more than 2 parts, that's okay. We for each part, look, we have another. But we have if that we say we have K equals 4, okay, and then we have another A here. Okay, A still appears 3 times, and then we can split into CCC and DE, right? Yeah, 3 parts. So what does it mean? The answer is the longest substring with every character appearing at least K times must be in this kind of, yeah, in these. We just need to solve these 3 parts, right? And how do we solve these 3 parts? We can do this recursively, right? So we are dividing the problem, bigger problem, into the smaller one. Yeah? Does it make sense? And then the answer will be the maximum of all the solution to the subproblem, right? Got it? Yeah? If we can't find any character, that's less than K, then if every character appearing at least K times, then what's the longest substring? If we can't divide it into the one group, so what's the
What do you mean?
so if we go through this, if K equals 1, okay, at least 1 time, A, B, C, D, E, F, G. So what's the longest substring? Obvious, that's what I'm saying. If you can't find any invalid, we call this invalid character, yeah? If we can't find any invalid character, then we return the length of the current longest, because that's the requirement, yeah? Got it? So first of all, the question is, the algorithm is simple. Well, first of all, we use the counter to count the number of characters and the number of times they appear, right? And then we go through these invalid characters and group these by this invalid divide, split by, yeah? We're using a split by these characters. And then the answer will be the maximum of all these subprograms. Okay? Yeah? Okay, let's write this. So it'll be easier to write. And then this algorithm is quite elegant, right? Define to SK. Okay, so how can we check? Look, C equals counter. First of all, we check the counter S, right? Right? And then we need to go through each character for let's say the key and value, yeah? Key and value in C.items. Yes? What's C.items? C.items return a pair, a tuple, key and value. The keys are the character, right? And the value are what? And the value are what? I said. The key value pair, what's key? Key is the number of, these keys are characters. And the value, what are the values? In the counter, remember, what are we trying to do here?
We're trying to brute force.
Yeah, I know. What I mean is the counter. If you use the counter object, A, B, C. So what does it return? What does it give us? Count out. You give a dictionary. A, what?
2,
B,
1,
C.
1.
Okay, so key value in C dot
And
item.
you can just look at it.
Yeah, I know. C dot items. It return a tuple. A, 2, B, 1, C, 1. Okay, so K is this, the keys. So the V, what's the V?
Hey, you haven't did the tuple on the C.
Yeah, I know. What's the value? What's this? What does it mean?
How much times it...
How many times they appear in the original string? Yeah. So the V is how many times they appear in the string. Right? Okay, so V, if V smaller than K, right? What does that mean? Yeah, if we found this K character, yeah, this is an invalid character because it appears less than K times, right? Yeah, now we need to do a split by it, yeah? We can split by it, right? So this S dot split what? K or V?
B. No.
K, V is the value, yeah? We split by it, and then we're calling the cell full, right? Right? Split by K, so we want to return what? Return maximum of full I, yeah, for I, full I, calling itself for IK, for I in S dot split what? Split K. Oh, we use another K, so let's not use the K here. C, okay, let's use the C. Okay. C for I, K is the number of times, it needs to be at least a K times. Then C is the character, so we want to split by C, right? Right? So we have S dot split by C, it will split the string by the invalid group. You actually remove the invalid characters. And then for each remember, if this is A, yeah, remember? A if it only appears if K equals 3, A only appears twice. Look at this, right? So S dot F split by A, so we have 3 groups. And we want to find out the answer, the maximum of the answer to these 3 subproblems, which is full IK for I in split that, right? Yeah? And if we can't find this, we return what? Return what?
Nothing.
If return what?
Nothing.
Huh? If we can't split, if we can't find any character which is less than K, it means all characters are appearing at most K, at least K times, so we return what?
3. Not whatever it...
Return what? Come on. I say K equals 1 and A, B, C, D, E. What's the longest? I just say, ask you. All of it. So, okay, so look, if we can't find any character that is smaller than K, so it means at this point, the whole string satisfy this requirement, which is every character appears at least K times. So we need to return the current length of the string, which is what? Length.
S.
Got it? Yeah? Remember, previous algorithm is O(n) cubic, right? Yeah, and for this one, it's what? It's O(n) what? Square, right? It's O(n) square. It's kind of O(n) square, yeah? Yeah?
This is still quite slow.
But it's better, it's far better. Yeah? You see?
Yeah, but it's still quite slow.
Why is it quite slow? Look, we first of all look at A, B, C. First of all, string, we go through this one time, right? And then we split by this. Or by this, and then we do this again and again. Do this. Right? Go this. So, yeah. Okay? Actually, I think it's O(n). Yeah? O(n).
Oh, that's pretty good.
Yeah, pretty good. Yeah, O(n). Especially if the S, if it only contains the, for example, if it contains the lowercase characters, so there's only at most O26n if we can do this O26n, which is O(n), right? Yeah. Okay. Got it? Because these C dot items, yeah, C dot items, group it. You only group it once, right? Got it? Okay, so which one do you think you can remember?
None of them.
None of them. Okay, so let me write this. Okay, so can you explain to me what's this divide and conquer? We call it divide and conquer.
What do you mean divide and conquer? That's a weird name.
What's this divide and conquer?
Divide means like dividing, separating, and conquer is like
So look, this is the dividing conquer. First of all, we divide this problem into a few sub-problems. And then we solve this. It's like recursion, we solve these smaller problems. Right? Okay? Does it make sense, Eric?
even in smaller problems.
Yeah?
Yeah.
So we have a bigger problem, and then in order to solve this bigger problem, we can divide it into three small problems. In order to solve this problem, we can further divide it. That's what it means. First of all, how do we divide? We first of all find the invalid character which is less than k times, right? Because we are based on this assumption that this invalid character cannot be included in any substring, right? It cannot be included in any substring. That's why what? That's why we can use it as the split. So when we split, look, if this is A, we split it. A cannot be included in the longest substring, so I can take it out, right? If any substring included A, what does it mean? It cannot be the longest substring, right? It cannot be the substring that satisfy this requirement. So we take it out. So the answer could be the longest substring could be in three parts. Could be in here, or could be in here. And look, yeah, we know how to solve this smaller problem, right? Until if we find if we can't find any invalid character, we just return the length of that substring, right? Got it? And this is your recursion, divide and conquer. Yeah, got it? Okay, good job. That's all for today. Good job. Bye.